today it is more evident that geolocation is becoming a necessity, indeed, almost an addiction. We need to know where we are at any given time. The most widespread tool to locate ourselves is the one usually known as GPS technology. We use it, for example, in our mobile phone every time we activate the location. Many games and applications that we use daily depend on it.
GPS uses artificial satellites that orbit our planet to locate us thanks to the signals received from them. Although GPS is the acronym of the American satellites, there are other constellations such as the European Galileo, the Russian GLONASS, and the Chinese Beidou. The acronym that refers to all the constellations and is most correct is GNSS, Global Navigation Satellite System. That means a system that uses satellites to locate us anywhere in the world.
These satellites are everywhere and continuously sending signals that we receive on Earth. Thanks to this, we can calculate the distance between us and the satellite. An easy way to understand it is the well-known equation, speed is space divided by time. Or in our case, space, i.e. distance, is equal to speed times time. Being able to determine the time this signal takes to reach our receiver, for example our mobile phone, and knowing that it travels at the speed of light, we can calculate the distance from our position to the satellite.
If we only know the distance to one satellite, we could not know our position. There are many points at the same distance from the satellite, forming a sphere. Adding a second satellite increases the possibility, but we would still be left with all the points where these spheres intersect, in the shape of a circumference. Measuring the distance from 3 satellites, we would reduce our positioning to just 2 possible points. Knowing the distance from at least 4 satellites, we can determine our position and time very accurately. We obtain this position in the form of coordinates, typically geocentric, x, y and z, or geodetic coordinates, latitude, longitude and height are used. Our mobile only allows us to know our coordinates to within a few meters. But we have good news! There are more sophisticated GNSS receivers on the market. They can give us coordinates with a precision of centimeters, or even to within millimeters, as in the case of permanent GNSS stations.
A permanent GNSS station like the one we have here consists of a receiver and antenna that receives signals from the satellites 24 hours a day. Its special design and solid construction allows us to achieve great precision at any moment in time. Thanks to this, we can measure displacements of several millimeters per year, such as the movement of tectonic plates.
There are GNSS stations all over the world, grouped into networks. For example, the National Geographic Institute has a network of more than 100 stations throughout Spain. In addition, there are others, such as the European Network of Permanent Stations or the International GNSS Network. Their data are public, and we can use them in many applications such as roadworks, agriculture, cartography, and various scientific applications to study our planet and how it changes over time.
Remember that behind something as simple as this, you can find something as complex as this.